It's a small town, small county. We have one stoplight, flashing light in the whole county. So if our driver's ed kids want to practice with a stoplight, they have to go up to the next county. It's a pretty typical classroom with textbooks and some basic chemistry supplies, and a lab room that was somewhat antiquated. If you had showed up there 50 years ago, it would probably look about the same. It's a different experience.
Ask a chemistry teacher in a rural school district to name the biggest challenge they face, and you're likely to hear one thing time and again.
We have one math teacher, one English teacher, one science teacher, and you have no colleague to bounce ideas off of, to hear new ideas from, to test out hypotheses and new philosophies and new strategies. That aloneness, people sometimes get stuck in a rut just because they're alone and they don't have any opportunity to stretch and grow and get new ideas.
The University of Illinois' Institute for Chemistry Literacy through Computational Science gives more than 100 teachers from the state's rural schools that opportunity to stretch and grow, and to develop a network of colleagues that they can tap for the rest of their careers.
You know, the old saying, 2 heads are better than 1. In my case, 54 heads are better than 1, and it's just very powerful that way.
Even though we only get face-to-face time here a couple weeks each summer, the electronic community that they have set up really helps out, because you're able to ask questions and get responses from essentially people who are at the same situation you are.
Funded by a Math-Science Partnership grant from the National Science Foundation, the ICLCS program is now in its 3rd year. While on campus, about 100 teachers refresh their chemistry skills and learn to use computational tools in the classroom.
One of the major pushes in education over the past few decades has been the addition of personal computers to the classroom. Unfortunately, in most instances, those personal computers are being used for very limited purposes. They may be used by the student to do searches on the internet for various types of information. They may be used to help compose a paper. But what ICLCS is doing is exposing these students to a new class of tools that allow them to understand complicated scientific concepts.
I don't think the content is necessarily the challenge, but finding a way to get to the student and get them involved and becoming a stakeholder in their own education.
With experts from Illinois' College of Medicine, Department of Chemistry, and National Center for Supercomputing Applications, ICLCS fellows explore tools that can do things like simulate chemical interactions on supercomputers, visualize and animate results, and allow students to construct dynamic models that they can run themselves.
You're talking about things that you can't see, and trying to get some students to understand mentally what's going on is very, very difficult.
In order to try to get my students to visualize the structure of the atom with the quantum model and the orbitals and where the electrons are, I would have no tool but to go to the blackboard and draw them and have the students draw them. Now with the tools that I've been given, I can create those 3D models virtually. They can turn them around in space. They can see the correct geometry. I don't have to write on the walls of caves anymore.
During their summers at Illinois, the fellows also brainstorm ways to use these tools. When fall rolls around, those ideas hit the classroom.
Last year, we were looking at the idea of energy in a carbon compound, in methane, natural gas, butane, things like that. And so our activity was to have them actually build these basic molecules in the computer, send it to be calculated, and then using the information that they got back to see if they could find any consistent trends in the energy that would be released from these molecules were you to burn them.
It's discovering the concept yourself, and it may seem like a little more work than the teacher just telling you, but you have ownership in it when you worked for it. So it becomes more part of you, you're able to remember it better.
Computational tools actually come in and fill that gap between the driving phenomena and the world that the student sees around them. And that kind of skill is going to be extremely valuable no matter what type of job they end up doing.
You feel like, okay, I'm from a real small school. Nobody's going to offer me any help. This program was designed for us. And everything the staff does is done to empower us. They listen to us, they modify, they change as we tell them our needs. Wow. I mean, that's never been done.
The University of Illinois' National Center for Supercomputing Applications provides powerful computers and expert support that help thousands of scientists and engineers across the country better understand our world. With the computing power available at NCSA, researchers create computer simulations with real-world social and business impact. NCSA is supported by the State of Illinois, the University of Illinois, the National Science Foundation, and other federal agencies.